Greetings of the day. In the last session, we discussed about types of lasers and pumping schemes and pumping methods. So today we are going to discuss the next topics here, helium neon laser. So this is a laser device or laser instrument which has different applications in different fields here. Now in this session we are going to discuss what is the construction of this helium neon laser and how it works for the production of laser and its main application in this session. If you see helium neon laser, the helium neon laser is a gas laser. So in the last session we have discussed about types of laser. In the previous session we discussed about the types of laser. Solid state laser, liquid laser, gas laser, semiconductor laser. So this is the classification of laser based on medium, that is gain medium. So these gas lasers has very good application when we compare to solid state lasers. So see, the solid state lasers will produce laser, but the output that was given by the solid state laser will be pulsed in the most of the cases. Whereas these gas lasers will produce continuous laser as output, and at the same time this gas laser even effectively work at room temperatures. And there are different modes of gas lasers are there. These gas lasers ranges from low power mode for commercial application to high power mode for industrial applications. If you see these low power lasers, gas lasers can used in laboratories and in supermarkets for reading barcodes. Whereas these high power gas lasers are used in industrial purpose for cutting, drilling and welding and for different other purposes. And these gas lasers have the atoms in which the energy levels are very close to each other. As a result, we should use a pump source which gives the exact energy or a low energy. We make the atom to transit between these energy levels. So therefore, we use a pumping method in gas lasers, that is electric discharge. In the last class, we discussed about the different pumping methods like optical pumping, electric discharge, inelastic atom-atom collision, and other pumping methods. Among all the pumping methods, electric discharge method is very good, suitable method for the gas laser to produce lasers, because these gases have an atoms for which energy levels are very close to each other. Therefore, if you use optical pumping, because the optical pumping will produce light or photons of broad frequencies, which is difficult to make atoms to attain population inversion. So therefore, we use this electric discharge method. This electric discharge method will give the exact energy, the suitable energy for atoms to go to exact state and produce population inversion. That's why these gas lasers are used electric discharge. All the gas lasers use the pump source or pumping method as electric discharge method. And in this electric discharge method, this we use high power voltage, like DC voltage, and because with the help of this voltage, we produce a discharge or gas discharge in the gas laser, which makes atoms to go to exact state and produce laser. This is about gas lasers. If you see about helium neon laser is one of the gas lasers. And this helium neon laser is a gas laser. And this gas laser works under the pumping scheme of a 4-level pumping scheme. It is a 4-level pumping scheme. Already we discussed in the last class what is 3-level pumping scheme and what is 4-level pumping scheme here. The helium neon laser falls under 4-level pumping scheme here. And this helium neon laser is designed by Ali Jawan and his co-members. Ali Jawan and his co-members. Okay, and this helium neon laser is a low power gas laser which uses as it is a low power laser, it can be used in commercial applications. Now this is about gas laser. If we see the construction of this gas laser, now we know that once we need to remember that if it is a gas laser, they use discharge tube because the gas has to be enclosed in a certain thing that is called a discharge tube. Now here it is the discharge tube. You can see this is the discharge tube here. This is the discharge tube here. So this is the outline I am showing you. This is the discharge tube here. So this is the discharge tube here. And this is the discharge tube here. And this discharge tube is made up of quartz. The discharge tube is made up of quartz. So why it is quartz is because the quartz is a material which has an ability of absorbing infrared radiations. That's why we use here quartz to enclose helium neon gas. So why we use quartz, we can understand in a better way when we discuss about working here. Now this gas discharge tube is made up of quartz, and this discharge tube enclosed with a mixture of helium neon. Now you can see this is the mixture of helium neon, and this mixture is in the ratio of 10:1. The mixture is the ratio of 10:1. That means 10 atoms of helium and 1 atom of neon. So here the ratio of helium neon gas is in the ratio 10:1. The 10 represents, the ratio 10:1 represents the pressure ratio here. This 10:1 represents pressure ratio. That means the helium atoms are enclosed at a pressure of 10 mm of Hg, for example. 10 mm of Hg. Then neon atoms are enclosed at 1 mm of Hg. So the ratio 10:1 represents the pressure ratios of helium neon in the discharge tube. And now, this discharge tube contains electrodes. This is one electrode and this is one electrode. This electrode is cathode and this is anode. These two electrodes are connected to high power DC supply. And now, from this we can understand the pumping method is electric discharge method. And the two ends of the discharge tube is enclosed with a windows which are called as Brewster windows. The two ends of the discharge tube is enclosed with two glasses. Those are called Brewster windows, which are placed at, you can see these are placed at an inclined position at an angle called a Brewster angle. Okay, so why they are placed at Brewster angle, we discuss in the next session here, in working here. And on the axis of the discharge tube here, it contains two mirrors. This is a 100% reflecting mirror, and this is a partially reflecting mirror. And the combination of these two mirrors is called as optical resonator, and this optical resonator is named as Fabry-Perot resonator. It's called Fabry-Perot resonator. This is 100% reflecting mirror and this is partial reflecting mirror. The combination of these two mirrors is called as an optical resonator, which is in the last session there. And this optical resonator is called as Fabry-Perot resonator. Now this is the construction of helium neon laser. If we see again the construction of helium neon laser. So the helium neon laser contains a discharge tube, which is made up of quartz. So here the discharge is made up of quartz because the quartz material has the ability to absorb infrared radiations, and the discharge tube is filled with the mixture of helium neon in the ratio 10:1. The ratio 10:1 represents the pressure ratio, not the concentration of helium and neon atoms. It does not represent 10 atoms of helium and 1 atom of neon. It represents the pressure ratio between helium and neon is 10:1. That means 10 represents, for example, 10 represents 10 mm of Hg, then 1 represents 1 mm of Hg. That means the helium neon is enclosed at a pressure of 10 mm of Hg, and neon atom is enclosed at a pressure of 1 mm of Hg. So this is a pressure ratio of helium neon, and the discharge tube is enclosed with the 2 electrodes, and the electrodes are connected to high power DC supply, and from this we can understand the pumping method is electric discharge method. And the discharge tube is enclosed with the 2 windows which are placed at Brewster angle. And those glass are called as Brewster windows. And on the axis of the discharge tube, it contains 2 mirrors. This is a 100% reflecting mirror, and this is partially reflecting mirror. And the combination of these 2 mirrors is called as optical resonator. And in the helium neon laser, the optical resonator is called as Fabry-Perot resonator. This is about construction. That means how this laser device is designed and how these 3 components are enclosed for the production of laser. So already this is in the last class. What are the major components of laser? So there are 3 components. One is gain medium, and one is pump source, and third one optical resonator. In this helium neon laser, the gain medium is the mixture of helium neon. So this is active medium or gain medium. So that is the first component here. The second component is pump source. So here the DC power supply is pump source. Third component, optical resonator. The Fabry-Perot resonator is optical resonator. So these are the 3 components here. So if you take whatever the type of laser, whether it is solid state laser, liquid laser, gas laser, or a semiconductor laser, or dye laser, the laser contains these 3 components majorly. One is active medium, pump source, and optical resonator. So we see how this helium neon laser works here. Now see, we understand the helium neon laser, the active medium is helium and neon atoms. And these helium and neon atoms are responsible for production of laser. Now we see how the laser will be produced with the help of helium atoms and neon atoms. Now if you see, this is called energy level diagram of helium atoms and neon atoms. If you observe the energy level diagram of helium atom, it contains 3 energy levels. So energy level 1, energy level 2, energy level 3. So here the energy levels of helium are represented by F1, F2, F3, in order to differentiate the energy levels of neon and helium. And if you observe neon contains 6 energy levels: E1, E2, E3, E4, E5, and E6 energy levels. Now these energy level diagram of helium atoms and neon atoms. Now when the power source is switched here. When this power source is switched on, electricity will pass through this gas. And when this electricity passes through the gas, ionization of gas takes place in the discharge tube. Ionization of gas takes place. That means helium atoms will become helium ions and neon atoms will become neon ions. That means when we pass electricity, the gas discharge tube contains free electrons, helium ions and neon ions. These free electrons are produced due to ionization of helium atoms and neon atoms. So before supply of power supply, the discharge tube contains only helium atoms and neon atoms. When the power supply is switched on, ionization of gas takes place and the discharge tube contains helium ions and neon ions. And now these are the helium ions which are in ground state. Now, with the continuous flow of electricity, now we have free electrons in the discharge tube. That free electrons will gain energy and the kinetic energy will be increased. As a result, the free electrons which are in discharge tube will gain energy and they get collision with the helium ions. So, energy transfer will take place from free electrons to helium ions. So, these free electrons will gain energy and as they gain energy, they move in the discharge tube. While moving, they bombard with these helium ions. That means they get collision with the helium ions. As this collision is inelastic in nature, energy is transferred from free electrons to helium ions. As a result of the collision between these high energy electrons and ground state helium ions, the helium ions gain energy. Once they gain energy, what atoms will do? They go to excited state. Here, these helium ions will go to energy state F3 and energy state F2. So the energy of the electrons, the energy of the helium ions, which are in F3 possess the energy of 20.61 electron volt. And whereas the helium ions which are in F2 will possess the energy of 19.81 electron volt. Now, these helium ions gained energy. As they gain energy, the kinetic energy increases and they go to excited state F2 and F3. And now the helium ions which are excited to energy state F2 and F3, they do not simply come back to the ground state F1 automatically. Now when they go to excited state, the helium ions will gain kinetic energy and will move in the discharge tube. While moving in the discharge tube, these helium ions will get inelastic collision with the neon ions. These high energy helium ions which are in F2 and F3, the high energy helium ions which are in F2 and F3, they move in the discharge tube and get inelastic collision with the neon ions. As this collision is inelastic in nature, energy is transferred from helium ions to neon ions. As a result, these neon ions will go to excited state. To which states? E6 and E4. Why? Because, see, the helium ions which are in F3 will possess energy of 20.61. When they collide with the neon ions, they transfer energy of 20.61. And this energy level of F3 is equal to energy level of E6 in neon, which is 20.66 electron volt. If you observe this energy level of E6, it is slightly 0.05 electron volt greater than F3. And this small difference will be given to neon ions from the kinetic energy of helium ions. As a result, the neon ions will go to 20.66. And we observed F2, they have 19.81. And if these helium ions collide with the neon ions, they transfer energy of 19.88, and as a result they go to E4. Why? Because E4 has energy of 19.76 electron volt. So therefore, when the helium ions get inelastic collision with the neon ions, energy transfer takes place, and neon ions will excite to energy level E4 and E6. And if you observe in the neon, energy level E2, energy level E4, energy level E6, these three energy levels are metastable states. These three energy levels are metastable states. In the last session we discussed the three requirements for the production of laser is, first one is presence of metastable state. What are the metastable states? Metastable states are the energy states where the atom has a lifetime of 10 to the power of minus 6 seconds to 10 to the power of minus 3 seconds. So in the neon, E2, E4, E6 are metastable states. Okay. So now you can understand why we have chosen helium. Because helium has the energy level F2 and F3, which are approximately equal to E4 and E6 of neon. That's why we have taken the help of helium to make the neon to produce laser. So helium is helping the neon atoms to excite to metastable state. So that process has been reached for us. Now, when the neon atoms are excited to metastable state, so in metastable state we know that the lifetime is 10 to the power of minus 6 seconds to 10 to the power of minus 3 seconds. It is a very large time for the atoms. So that means as the time goes on, helium atoms transfer energy and again they come back to ground state. Again what happens? Electrons collide with the helium. Helium goes to excited state. Again they make other neon ions which are in ground state. They transfer energy to neon ions and neon ion goes to excited state. As the time goes on, the population of neon atoms accumulate at E6 and E4. That means as time goes on, helium atoms continuously transfer energy to neon ions. So therefore, neon ions will continuously excite to E4 and E6. That means the number of neon atoms will increases in energy state E4 and E6 as compared with the E1 and other states. So therefore, there will be more population in E6 and E1. Okay. So as more population increases at E6 and E4, the condition of population inversion is achieved here. How? So you can see the diagram here. If you observe, no neon atoms are excited to E2, E3 and E5. We have taken the help of neon to make the neon ions to excite E4 and E6. If you observe, there are four, for example, 4 neon ions are there in E6. That means N6, for example, N6 represents population density in E6. N5 represents population density in E5. N4 represents the population density in E4. N3 in E3. N2 in E2. N1 in E1. Now if you observe, the population density of N6 is greater than N5. The population density is achieved between energy state E6 and E5. What is the population inversion? Number of atoms in higher energy state should be greater than the number of atoms in lower energy state. So there are no number of neon ions in E6 and no neon ions in E5. So therefore the population inversion is achieved between E6 and E5. If you observe, N6 is greater than N3. That means the population inversion is achieved between E6 and E3. E6 and E3. And if you observe, the population inversion, that means N4 is greater than N3. the population inversion is achieved between E4 and E3. So in the helium neon laser, we achieve population inversion between three energy levels. One population inversion is between E6 and E5, and one population inversion is achieved between E6 and E3, and one population inversion is between E4 and E3. So we have metastable state. The second requirement, population inversion is achieved. Third one, it gives a stimulated emission. Okay. Now therefore, as population inversion is achieved between so the population inversion is between E6 and E3. So once after population inversion, we have seen the last session, the lasing action, how the lasing action takes place. First absorption takes place, and they go to metastable state, and initially spontaneous emission will start, and with the help of the photon which is emitted by spontaneous emission, we start stimulated emission, and the photon density increases and laser will be emitted. So therefore, the lasing action will take place, that means stimulated emission will take place between E6 and E3, E4 and E3, and E6 and E5. So between these three states, the stimulated emission will take place. Okay, if you observe here. So the population inversion is achieved between E6 and E3, and it produces stimulated emission, and stimulated emission will give a laser of wavelength 6328 angstroms. 6328 angstrom. So population inversion is achieved between E6 and E3. Once the population inversion is achieved, it produces laser of between E6 and E3, the population inversion is achieved. Once the population inversion is achieved, one neon ion will make spontaneous emission and it produces photon. If this photon, so for example, this photon is moving parallel to the axis of the optical resonator, as it moves parallel to the axis of the optical resonator, it reflects back. When it reflects back, it acts as incident photon, and it starts stimulated emission, and stimulated emission goes on continuously, and it produces a laser of wavelength 6328 angstroms. Okay, so in this helium neon laser, we get one laser whose wavelength is 6328 angstroms, and this laser falls in the region of visible spectrum. What is the wavelength range of visible spectrum? 4000 angstroms to 7000 angstroms. So this color of the laser is red color. So from the helium neon laser we get a red color laser. And we have another population inversion between E6 and E5. Between E6 and E5. So between E6 and E5, the stimulated emission takes place and it produces laser of wavelength 3.39 micrometers. 3.39 micrometers. And another population was also achieved between E4 and E3. And between E4 and E3 also, stimulated emission takes place and it produces a laser of wavelength 1.15 micrometers. Now this 3.39 micrometers and 1.15 micrometers is the wavelength which falls in the region of infrared. So these are in the region of infrared. Okay. So like this, lasing action will take place, and helium neon laser will produce three lasers as output. One is red laser, whose wavelength is 6328 angstrom between energy levels E6 and E3. And other laser will produce with a wavelength of 3.39 micrometers between E6 and E5, and one is 1.15 micrometers between E4 and E3. These two, that is 3.39 micrometers and 1.15 micrometers, is the wavelength which falls in the region of infrared. So once the lasing action completed, all neon ions will come back to E3 by stimulated emission. After E3, they make spontaneous emission and come back to E2. By making spontaneous emission, they come back to E2. Now, E2 is a metastable state. Already we discussed. E2 is a metastable state. As E2 is a metastable state, more neon atoms are accumulated at E2. That means neon ions will stop E2. That means they stay for a long time in E2. As they stay for a long time in E2, suppose there are 10 neon ions are there. All the 10 neon ions are jumped to E4 and E6 with the help of helium ions. When these 10 neon ions jump to E6, E4 and E6, they make spontaneous emission and come back to E2. So they stay in E2 for a short period of time. Meanwhile, there are no neon ions in the E1 for the helium ions to transfer energy and neon ions to go to excited state. Since there are no neon ions, neon ions will go to E4 and E6 because all neon ions are accumulated in E2. As a result, no neon ions, no jumping to E4 and E6, no population inversion, no stimulated emission, and no laser. That means once the laser is produced for a period of time, for a period of time, no laser will be produced. And again, after some time, neon ions will come back to E1, they collide to helium ions, and they go to E4 and E6 and they produce laser. That means helium neon laser will produce a laser as output for a short period of time and absent for a bit of time. And again, produce laser for a short period of time. That means here we get a pulse laser as output, not continuous laser. So in order to avoid this drawback, while constructing helium neon laser, the discharge tube is made narrow. As the discharge tube is made narrow, the neon ions which are in E2, they get collided with the walls of the discharge tube. Since they are colliding with the walls of the discharge tube, these neon ions will lose energy and they come back to E1. So by making collision with the walls of the discharge tube, we make the neon ions come back to E1. As a result, at any moment of time, there will be neon ions in ground state. As a result, the pumping of neon ions to E4 and E6 will continues, and we get a continuous laser as output. Okay, here we made an arrangement in designing the discharge tube to produce a continuous laser as output in helium neon laser. Okay, and one more thing you need to remember here. In the last classes we studied that the characteristics of laser. What is the first characteristic of laser? Laser is monochromatic in nature. Monochromatic means single wavelength as output. But if you observe here, the output of laser is three wavelengths. One is 6328 angstrom red color laser, and two wavelengths which are called in infrared, 3.39 micrometers and 1.15 micrometers. So it is a combination of three wavelengths. And laser is not a monochromatic, it is a polychromatic. So here we made an arrangement while designing the discharge tube. We already discussed in the working. The discharge tube is made up of quartz. And the quartz has the property of absorbing infrared rays. Therefore, these 3.39 micrometers and 1.15 micrometers are absorbed by quartz. And what is left in the discharge tube? Only 6,328 angstroms is left, and it is made as output. So therefore, the main output of helium neon laser is 6,328 angstroms. If you go to supermarket, you can see the reading of barcodes with a laser. You can see that is red color. That is helium neon laser. What you see in supermarket, where we are reading the barcode, that is helium neon laser. Okay, this is about helium neon laser. If you see the applications of helium neon laser, the helium neon laser is used for the purpose of measuring distances. Measuring distances. You can use the helium neon laser. And helium neon laser is used in reading barcodes. And helium neon laser also used in CD players for reading for reading CDs. And also you can use in our laboratory purposes to find the characteristics of laser and for the diffraction of light laser. So here these are the applications of helium neon laser. So in the next class we see the further topics of laser. Thank you.